Welcome to this afternoon session about system hardening, security system hardening. My name is Markus Meissner. I'm Technical Project Manager at SUSE, working in the security team for now 12 years. And my colleague here is Greg Gardner, formerly an admin, so he knows the system administration stuff, now a team lead of the storage team, working on the enterprise storage product that we have. And I will be mostly talking about what to think about, how to approach system hardening on a design, on a fault level, on a top-down level, and also will go into detail into some of the details that we supply with the SUSE Linux Enterprise server. I have to click now. No, I can do it. Yeah. So why not start with the details? The idea is, of course, that if you have a checklist, it will not directly apply to your cases, because you live in different environments, you have different preconditions, also different views on a thing. So, but let's start with one fault that is the core fault of hardening. So derived from a software security standpoint. So what is good software? The good software is it does what you expect it to do and does it well. And secure software builds on top of that. Secure software is good software that does nothing else. So it doesn't have unintended features, unintended side effects, unintended security issues. And the same can be applied also to systems. So you want your system to do this task that you designed it for, and it should not do anything else. And there the hardening comes in. The hardening tries to reduce any kind of potential attack surface to the system, to avoid attackers using these kind of additional things or these kind of insecure interfaces to your system. So starting to look at hardening, we of course need to know what the system should have for a purpose. So basically, what is the real purpose of the system? Because otherwise we cannot know what to reduce or what features to remove or what features to look at. We need to know the lifetime. Lifetime concerns are important because it's usually not a one-time issue that we are facing. So we need to think also about maintenance of the system. So hardening is not really a one-time thing, but it is an ongoing topic because the security scene develops, bugs appear, and so on. We need to know the capabilities that the system should have, how much data, what Ethernet interfaces, what network interfaces, and so on. And we need to know on a medium level then where should it be on the network, because our hardening will be different if it's connected to the internet, if it's in a DMZ, if it's in a company intranet, or in a very protected VLAN somewhere. The compute location is, of course, also interesting if it's in your data center, in the cloud, at a different service provider or someone else. That also influences the hardening decisions. These days, we have not just physical machines, of course. Virtual machines or containers also have some different approaches on deployment of the hardening methods, or on some of the parameters. Similar cluster setups, geo-cluster setups, and specifically also private cloud or public cloud setups. And in the end, of course, it turns out to requirement lists that turns into checklists that need to be applied at some point in time. Hardening starts usually at there can be two different entry points. You build up the new system from scratch, where you control everything, where you can be sure what you have, where you can rely on that it starts fresh, and where you can really specify what you want. You can really do the changes that you need. And the second one is you get a system and you get the task of hardening it after the fact, and you rely on potentially slightly faulty documentation, some undocumented changes on the system, and that is usually a bit more interesting to find out what is happening on such machines, and needs a bit different approach. Decision factors that you do during your hardening, I talked about the purpose. You're also operating not inside a vacuum in your company. You're probably not the only sysadmin there, but or the only CIO that handles this, but you're operating within a team. You have common rules, common procedures. You need to you can't just override other team decisions with your work. And of course, your company needs to follow, probably has a set of standards that it follows, be it PCI DSS, government standards, or your own set of standards. You're operating within the infrastructure parameters, like I said, a network location, firewalls, and so on, security zones. And your company or whatever your organization has already requirements on how stuff is deployed, how stuff is installed, what is the configuration management, be it the / built-in methods or third-party tools. Also, the monitoring system is you're operating within a monitoring infrastructure, and there are maintenance rules and also decommissioning rules for such systems. Deployment philosophies that influences also how the hardening is approached. So in old times, you installed machines manually, you put in the CD, you installed it with Yast or some other UI tool. You brought up the machine and you kept it running for a while. You added services, removed services. But this is not really the current state of the art. The last 10, 15 years saw more and more automated deployments where you automate the deployment with manifest-based installations with SaltStack, Puppet, Ansible, and so on. And it also brought a feature that the installation of such a machine doesn't take that long because it's not a manual process anymore. And it made the installation much easier. So bringing up a machine for a single task and tearing it down afterwards become very easier and so become more of the norm. And this is different between having a big machine running for a while and changing stuff on this big machine. And quite a bit newer are the concept of containers where people bring already pre-built container images to you and you have to run them or you have to look at them and look at how you can harden those containers, container contents. That plays into also the lifetime philosophies. So the previously manual big machines, they were kind of dynamic. So services were removed and added on demand. So like we need this Apache web server for the next 2 years, or this database server is needed for the next year. But now it's no longer needed. Also, user management was done on those machines, removing and adding users over the lifetime. But with the modern deployment methods, with the virtualization coming up, usually we come into a more static scenario where you have a single task, single set of users for a fixed lifetime, and then the machine is thrown away. That makes the static setting makes, of course, the hardening easier because you don't need to document that much. So going into installation and setup, the parameters that we look at the hardening is the package, the software that is installed, what you will install, like the services itself that you need, and also the administrative packages and their dependencies. Interesting there, of course, packages will come from from an operating system vendor, for instance, SUSE, but also from third-party vendors or your own in-house software. And that needs to be considered, that needs to be taken care of, because in a later maintenance cycle, we have to think of how to get updates for all those packages, not just from SUSE, but also from the third parties. Users, you have to know which users should be on there, which service users, which administrative users. Again, this is a thing where your company might have rules that there's a database user, or a shared database user, or a shared system administrator user, or something like that. For network interfaces, machines these days have a lot of network interfaces. The physical machines have lots of Ethernet cards. The virtual machines have lots of virtual bridge interfaces. And you need to know what the machine should have, and only those should be actually configured on the machine. Not that some administrator leaves a debugging interface up for a while that would make attackers that take over your machine suddenly able to access your company intranet or something. So it really should match what was designed for this machine. And you need to be aware of that this needs to be verified occasionally. Data's, again, a big concern. Access to the data should be limited, if possible, only to the server, only to the stuff that is needed on the system. So, excuse me. So basically, to avoid either information leakage from the system via read-only access to data, or as we saw in the last 2 years, the more and more increasing ransomware trend that ransomware, if it would infect your system, could encrypt your company data. So that there really should, so you need to try to reduce the access to the data to just a necessary one. And a large part of that is also that decisions, setups, and so on needs to be documented, because you likely don't operate alone. You forget things. You have a lot of machines to take care about. So you should be having some form of documentation system. You likely already have. So and document that and keep the documentation up to date. So packages, hardening itself has the concept of minimization of the attack surface. And of course, minimization of the attack surface also means that we minimize the installed packages. We start deploying the machines with the minimal set that is needed. The SUSECON's enterprise server brings a minimal base pattern that just contains the base package to start up the system and the package management. That's all quite minimal, but we also supply, for instance, a so-called JUICE image, just enough operating system image, which is even more smaller, but can be extended with packages up to a full slash size if there's need. But both the minimal set or the JUICE images are, for instance, good starting sets. You can, of course, also go in later, remove stuff from regular slash and see if that works. Here we have the different deployment methods again. So if you do a manual installation, SUPERYAS2 will likely be used. For manifest-based things or salt, there are the specific manifest salt.package calls. And for Docker, we have Docker scripts or other Docker creation tools. Yeah. The interesting part is, of course, that the hardening the system can be done in this manifest deployments and Docker scripts deployment the same time, or the reduction of packages should be done at the same time that you design and set up the needed packages for your installation. System settings. So a lot of the hardening methods described are modify this value in that file, this system control setting, and so on. And here we again, depending on deployment, differ how you would do that. So the manual deployment methods, you would take a text editor, take a YAST module, or a third-party management software on the system that can change those values. We have a specific YAST2 security module that tries to centralize that in one single module, where you can click and select it on a long list of checklist items. For automated deployments and containers, I would recommend for hardening that you also encode it directly into the manifest, so and the Docker scripts, so that you don't need to do it after the fact, that you don't need to do 2 steps. And that's actually pretty easy. For instance, the salt, there you can specify the configuration files and their permissions, or even content things. So here should be the YAST2 security module, but I was unable to fix my slide. Well, I was unable to replace the slide, so we can briefly show it. but it's a not yet fully hardened crater lake.
It's like a metaphor.
Yeah.
Get to it from the security section here in YAST, the security center and hardening.
Yeah, and okay, still starting up. Okay, yeah, so basically you have a simple list of sections that we have, and also a simple list of things that you can change. So like changing the sysRQ key, enabling the sysRQ key that would allow local users to either boot the machine or not, or things like the IP4 forwarding setting, or remote root logs, remote logins in SSH. So some of the common hardening features are implemented in this module that you can look at, and with single checkboxes you could, at that point, change. So after installation of the system, you would, then of course the interesting part is also the maintenance. So what are lifetime maintenance concerns? One big point is applying maintenance updates. Why? We fix the security bugs, so we reduce the security attack surface to your system, because not every security bug can be worked around or blocked. And one interesting part is there, of course, that you don't need to just take care of the SUSE updates, but also of the installed third-party software. I had a customer, I think 2 days ago, who told me that, yeah, you supply updates to OpenSSL, but our partner software embeds OpenSSL and we don't get updates for that. So in that case, you have to pressure the software partner to not use their own copy or to update OpenSSL. Interesting part is also monitoring. Monitoring especially not just for the common use cases, but also monitoring for security incidents in your log files or in other parts. I mentioned backup and recovery, but that's also a common use case and not directly related to hardening. SUSE Linux Enterprise includes also a more structured logging method called the Linux Audit Framework. The Linux Audit Framework is out of the box able to monitor the user management, like adding and removing users, also modifying users. These will be logged with the calling user, what happened and what was done. And also the user access, like if users log in via SSH, if users run cron jobs, if users access the system via FTP, also if when users log out will be logged. That uses directly the user management stack, so it cannot be worked around or cannot be bypassed by users. That is interesting if you want to know things after the fact, if someone logged into your system and you were not aware of that. This would make you aware of such facts. What the auditing framework also can do is monitoring files and directories, even for read access or for write access. So if you have some sensitive data that you cannot protect with Unix permissions, you could monitor it and see if someone has accessed it, if he had some human requests not to access it, like company secret data, but that still needs to be readable on the machine. Also, the Linux Audit Framework can monitor system calls. So you can list what system calls you want to monitor in the config file, but it's very low level and it's probably not actually needed for common hardening scenarios. It will log to varlog audit, to a directory called varlog audit, and process with included tools. Or it can also be delivered to a remote system. Similar, like the syslog could also be delivered to a remote syslog service. What other lifetime changes are interesting from a hardening perspective? So the last years saw increasing security research on cryptography, and the end of lifetime of various ciphers. So MD5 has been gone for some years. I've not even listed it anymore. But this year we got told that RC4, that triple DES, that Blowfish are finally no longer being used because their RC4 had cryptographic attacks, successful ones, and triple DES and Blowfish are now so small block cipher, so small block ciphers that they can be attacked using 2 days compute methods or compute power. This is something that needs to be aware of because a lot of services, a lot of SSL using services specify the ciphers in their config files. You need to go and review those config files if the current cipher list is up to date. Similar for protocols like SSL version 2 was finally security-wise demolished in February this year. So security researchers really made it pretty much useless with their research. Also protocol version 3 is mostly no longer recommended. Similar for SSH protocol version 1. Other lifetime concerns on a machine is SSH keys for machines or for users. If users leave the company, their SSH keys should, of course, be removed from the access list from authorized keys, similar for host keys. And SSL certificates. This is, if you're offering a SSL service, then the certificates will expire at some point in time, and you will likely have some infrastructure on replacing them. The cipher method changes is documented in our documentation, also in our technical information documents, TIDs, or in the software's documentation itself. Also documented usually by rules from the auditors and auditing guidelines. And we try to ship a secure default in our configuration files, where you can take them and merge them into your configuration. Purpose changes. So that's something that if you're doing still dynamic systems where you don't just make single task systems, for such systems, the stuff should be documented. There should be a service phase in and phase out process with updating the documentation, removing or adding the data, and similar also for users and data on the machine. So that if someone comes to the machine and that services, even after they are not used, are not running anymore. And the documentation is, again, a requirement if people operate in a team, or if you take over the machine from an earlier sysadmin, or from if your successor takes over from you, that he knows exactly what should be on there. So here documentation is the key, and actually following also not just the phase in, also the phase out processes. User management. If you're doing user management, the interesting parts are adding users, removing users, of course, removing users if they are no longer need access, and the password policies. Password policies are one important point of hardening. Well, let's face it that users are occasionally also a weakest link when attacking systems, especially if you're using password-only access. Bad passwords by the users will be an easy entry vector for worms and other attackers. So your guidelines will have probably acceptable password rules with numbers, special characters, and so on that need to be codified. There is usually a change time where you have to, cycles in which you have to change the password, and also some method of handling failed logins, like locking the account after 3 failed logins. But mostly you will probably not have the users on your local system standalone, but for human users there usually is a centralized user management that needs to be taken into account also. I mentioned also two-factor authentication that helps avoiding this password problem a bit, but it might not be applicable to all scenarios of user management. What is the Linux method of account handling? That's mostly the PAM, the Pluggable Authentication Module standard. The configuration lives in the ECC pam.d files. For every service that handles user accounts, user logins, there's a configuration file, and it includes other common settings files for authentication, for account, and for session handling. And these include files have specify what the system actually checks. So if it uses etc password checking, if it uses Kerberos 5 or similar. Tools to handle accounts. We have the just2 users module that can create, remove users if you do that manually. We have the user addition, user add, user there, user mod tools that basically do what the name says, similar for groups. For deployment methods like salt or manifest, they also have methods of specifying user creation or user removal in their meta language usually. One tool that we have, a command line tool, is pamconfig. Pamconfig does not modify the users, but it modifies the authentication stack. So it can enable and disable or add or remove PAM modules from the authentication stack. It also can configure them. That can be, for instance, used to add tools for the failed login handling. So the failed login handling is done by the pam-tally2 module in PAM, where you can specify after how many tries, in which time frame should the account be locked. And the same tool, the pam-tally2, has a command line tool that can unlock users if the account has been locked after the fact. The other part is the password strength checking, PAM PW check, where you can specify character classes, which does dictionary word checking, and so can basically avoid that the user chooses a too easy guessable password. The password aging, so the change cycle of the password and other user creation details, they can be configured in a login.devs file. The login.devs file is also a simple text configuration where you can specify the permission of the home directory, the days after which a password needs to be changed, grace periods, and so on. That will be handled by that will be read by the user add command and written in a shadow database, for instance. One slide that I would have liked to add it later, but it's not in there, is about SSH. SSH as a remote login tool is one of the main entry vectors. If your system is facing the internet, you will get a lot of attempts to log into your system. So there are other recommendations like disallowing the root login on these systems. This would be the worst thing that could happen. Also, disabling the password-based login over SSH. That would, however, require that you set up the SSH keys, so full RSA keys, to identify users and to manage users. And also there's the possibility to avoid or to block such brute force attacks using firewall rules. So the SUSE firewall has a sample rule where you can, if you do more than 3 logins in 5 minutes or something like that, then you can block for 15 minutes any kind of logins from the same host. This is not really effective these days anymore because login tries come from all over the internet, and some botnets will rotate through all the IP addresses. So it's a scary world. So good passwords, disallowing root logins, and likely switching to SSH keys only is one thing that should be done for SSH hardening. And after the lifetime, when it ends, decommissioning the system itself. It's likely wiping the hard disk, checking that the data is no longer used, and hopefully not destroying important data. But wiping the hard disks is most likely done in every company. Updating the documentation so that the system is not missed somewhere. And of course, if you have references from the outside to this machine, like firewall ACLs that contains this IP address, DHCP entries, or so on, they also should be decommissioned. That should also be in some form of decommissioning plan. So that's if you are knowing what is on the machine, approaching the machine from a new angle, from an attacker, or from a here's the machine, do something with it angle. Auditing what is installed is interesting. So you need a plan on how to look at that. So basically, the best way is to approach it from the outside to the inside. So from the network, looking at the network ports, then looking at the services, at the processes, and also some files, and finding out what is good, what is bad, and or what is unexpected, what should not be there. Network, you can scan actually the machine from the outside to find out open network ports. Please clarify this with your IT team because they don't like that. They detect such things with their intelligent switches. You can also listen to network traffic. Again, if you do it from outside of the machine or from inside, please clarify it with the team. But it will show what actually happens currently. But of course, it doesn't help if a service is not talking. So it's, if it doesn't talk, then it will not be showing up in a network dump. So Wireshark is the UI and also a command line tool for that. TCP dump is also a command line tool for that. If you want to have non-sniffing things, non-active things, passive methods, so on the system itself, you can use netstat or a new tool called SS, like socketstat, to see what ports the system has open. Also with the associated program, the binary that listens to that port, and look and verify if that is what is expected on the machine. In preparation of that, I looked at my workstation at work and I actually saw two ports with random numbers that were not associated to a port. And I thought a bit about it. I let this Wireshark run for a bit, and in the end, I'm not fully confident, but I think also the Linux kernel occasionally opens ports, and because I saw RPC traffic coming from the NFS file system. So the kernel itself has some ports open when doing RPC, NFS, namely the stat daemon and I think someone else, the log daemon likely. So this, first I was kind of afraid that there is some form of infection, but it fortunately was something that is not easily visible. Of course, attackers, if they infected your system, could already hide such things. So that's, yeah, it's also a concern. Going to the services. For services, you can list them, for instance, with tools like checkconfig that works for both sysvinit and systemd, or the just2 services module if you want a UI module. For systemd itself, there's the tool called systemctl that can show the status of the system. It can enable and disable services. Enabling and disabling means for things like when booting the machine. It can also start and stop the services, which would be the immediate action. What we do as a hardening rule, and also what we have as a policy for our enterprise server, is that we only enable the minimal set of services by default. Especially every network service should not be enabled by default. So if you configure a network service, you also will need to enable it, so that not by just installing the package, you will suddenly have a service running that has a configuration that might be allowing attackers to break in. There's one small exception. When you install the system, usually also install the SSH service, but during installation, the firewall port for SSH will also be blocked. So, but without SSH running, and of course the firewall opened, you would otherwise not be able to log into the system if you install it not via the console. So this is something, SSH is one thing that we, I think, enable during installation, but not if you install it later. Yeah. So again, check the documentation, and if something should not be enabled, then try to find out why it is enabled and disable it. Processes. There will be things that are not covered by service files. The PS comment would show it, but these days it's quite a long list, especially if you're logged into a desktop. It would be a very long list. If you're logged in on a server, it won't be that long. Occasionally the names are identified, occasionally it's hard to identify the names. So if you want to find out what something is or what RPM something comes from, you can query with the RPM comment that, for instance, the NSCD that you see in a process list comes from a package called NSCD, which is not helping that much. But if you look at the RPM information, it says name service caching daemon. That makes sense, and that it is built from the glibc package by SUSE, so that's likely also a trustworthy service. Files. There are two parts of files. Files so permissions for programs, setuid, setgid permissions that give local users that run these programs more permissions. This is interesting for security, of course. These, the ones that are shipped by SUSE are tracked and also recorded in a permissions framework. The configuration for that is in etc permissions files, etc permissions.easy or etc permissions.secure. And there's a tool called checkstat that we include that can verify and also restore those settings of those binaries. It will handle only the files it knows. If some other binary has got a setuid bit, it will not notice that. So it's meant for the list of binaries that we supply that have special set something permissions. For the others, we include a tool called ZACCheck. ZACCcheck basically runs a cron job, looks over the file system, and sees if something suddenly got the setuid bit, or if some setuid bit got removed suddenly, or if there are world fileable directories or other suspicious files that suddenly appear. Runs in a cron job, will send you an email if something happens. You can then at that time verify if something weird was going on or not. The other part is integrity of files. So there are two parts of the installed packages, like the binaries and shell scripts, that can always be verified with the RPM comment itself, because RPM stores the checksum of every binary, every file it includes in its database, and with the verify option you can verify the installation of this binary. For our files, we have something called IDE, Advanced Intrusion Detection Environment, I think. If you heard of Tripwire, this is another version, a very similar version that does that. The idea is that you specify what files you want to track in a config file for it. You run it once, record the state, and on the future runs you can verify it if the state of the files has changed. Of course, if the content changes, then it's not easy to track it that way. Then it would be better held in a source control vision system. But for files that should have a config once and not changing, IDE would be a good tool for that. Of course, you can store the database locally. It has the possibility to put in a password so that attackers cannot easily modify it. But keeping it offline, if your system would get infected, is also a good idea. One part of protecting existing systems is using the AppArmor security framework. The AppArmor security framework is meant for confining applications and also for confining things like PHP web services. It's a whitelist approach, so there's a configuration file where you have whitelisting files that the application can access, can read or write. It can also whitelist binaries that are started by this application, and can also say that these binaries in turn are confined by other profiles. It is quite easy to learn, so it has a learning mode. You put it into learning mode, you run some coverage scenario, and then you put it into, after adapting the configuration with the supplied tools, you can put it into enforcement mode. And if if that again results in problems, hopefully not, then you can again incrementally enhance the profiles to cover all use cases. It's helpful especially for cases where you are limiting access to files, reading or writing. If you have a service or program that can write or should write everywhere, then it's hard to confine using AppArmor, because the whitelist approach, then you would need to whitelist everything, and that would not help much. But it's useful for confining services or applications that are limited in their file system access. So we are, for instance, confining our mailing list software on OpenSUSE.org, also other services on our infrastructure with that. So now coming to the checklist, so they're really the step-by-step instructions. We have a hardening guide in our SLES documentation itself. That's, I think, 100 pages of documentation. It's kind of scary, yes. Yeah, and we also have worked on, and I learned that it's not yet published, hardening guide specific to PCI DSS requirements, so basically an addition to the regular hardening guide that it's not that long, which will be published in the near future. And we are currently working together with the US military shared data center, the DISA, on a secure technical implementation guide for SUSE Linux Enterprise Server. These are US military approved hardening guidelines that should be applied by their system administrators on deploying the enterprise server, for instance. What is DISA stick project that we are currently doing is it's just a manual checklist currently. And of course, and I think it has like 400 something rules, which is kind of scary, which takes very long to handle. So, of course, people have started to automate such things and invented a new standard on that. Because if you need something, then you need a new standard. The new standard is called Security Content Automation Protocol. It has two main components. It has an extensible configuration checklist description format, XCCDF. On the fifth try, you will spell the correct numbers of C's and D's. So this is an XML description file which encodifies the rule set, basically. So it has in the XML the rules, it has the checks, and the description, some identifiers, and also remediation code. So it has a fixed section. The fixed section is mostly a shell script, can I think also be other kind of scripts also, or a manual suggestion on how to fix it. The checks are implemented in another XML language, namely called OVAL, Open Vulnerability and Assessment Language. In that language, you can codify things like the file, etc. Login defs has a line, UID max value 999 or something like that. So it can check content of text files, it can check RPM versions, it can check permissions, it can check running services, so that these kind of rules can be codified in OVAL, and the XCCDF language can reference these for testing the rules. The fixing of the rules, the remediation, is directly done in the XCCDF file. We ship currently the rule set, not the rule set, the tools to do it. The OpenSCAP tool is included. We have a minimal set of the rules that are also encoded in the YAS2 security module. We have encoded in the XCCDF file. So you can look at that and familiarize with that, because we are planning that we have in the mid-future, hopefully somewhere even next year, some form of SCAP profile, automatable SCAP profiles also for SUSE Linux Enterprise. So that, for instance, that we could automate the DISA stick checking and fixing, and also potentially others. So there's an open source project called SCAP Security Guide that we're also looking at. Likely we will be implementing one of those. The SUSE Manager has already support for calling this tool. We are just not yet supplying the rule set at this time. But we consider that important to have, and we'll see that we work on that. So with that, yeah, that would be. Have I forgotten anything?
We can spend another hour.
Yeah. So that's it from my side. I have some more recommended questions. I'm not sure if the next two are tomorrow, and the last two I don't know if they already happened or if they will still happen. So we will be talking about security certifications tomorrow, and also about Linux Security Essentials, even more entry-level approach. And SUSE Manager's audit capabilities talk. Capabilities talk? I don't know. Yeah, I saw one version of that, at least on Tuesday. So
I would only add that this year, in years past at SUSECON, we've had a limited number of recordings of these sessions. It is our intent that during this SUSECON, all of these audio recordings are made along with the presentation of the slides. So if you missed any of these, you might be able to still get some value out of going back once these are published and viewing these slides, in case you're interested in one of these that is on the list.
They will get available on the SUSECON website in the next days or weeks. Yeah. So, okay, so that basically concludes my talk. Are there any questions? Okay, so there.
Yeah, I have a couple of questions. First of all, you mentioned something about checking some suspicious ports that are opening, and then you have to track them down, and you put yourself at ease because you saw that was from a trusted package. What about if it is a product of a Trojan horse or something like that? Is it a way that you can check signatures, or a mechanism to see that this actually executable code is not a Trojan code?
Yeah, that's
because the name itself, it's going to put you at ease, but the legal malicious code.
If your system is infected, it's usually very hard to find out that it's infected. So the bad guys, they really know their thing. They have frameworks, tools that can hide their bad processes somewhere, also from the system tools. So you can never be sure. So if you know that your system is infected, the only way to be sure that it's good is to reinstall it. So, and finding such things, it's hard to find because they might be hiding somewhere. So I had a case where people infected I think the SSHD server or the named server, and sent with a special package, they were able to access the system suddenly. So that's really pretty much undetectable. So that's an interesting challenge on how to detect if the system is infected. That's kind of hard to do, basically. You would look for indicators like much more network traffic that you're expecting, or weird kernel crashes or something like that, but it's definitely not an exact science. Yeah.
If you don't mind my also responding to that, there are certain aspects of that really boil down to the system administrator's familiarity with the environment. For example, the example that Marcus had on the screen was the name service cache daemon. If you know anything about the name service cache daemon, you have certain expectation of what's supposed to be happening with that. If you see, as you're looking at the processes, that the name service cache daemon is actually a Perl executable rather than a C program running, native C, then you now have some indications that there is something wrong, right? So there's no cut and dried recipe for recognizing or solving those kinds of things, but familiarity with the system goes a long way to being able to say something's not right.
Yeah.
Well, yeah, actually, I was going to follow up on that because, as I said, I have a signature file or whatever you call the security enhanced Linux that you can keep signatures of modifiable files So there is or intrusion detection systems that you can monitor them. Because otherwise, as you said, you had a surprise. You said, what is that? You become paranoid and you have to isolate the system and do forensics and deploy another system, and it's going to be an endless cycle.
Yeah.
And of course, as the advanced intrusion detection systems will do, they will keep those kinds of signatures of certain executables and environments to help you with that. But depending on the level of intrusion that has taken place, it's also possible to falsify that kind of information, which is why it's nice to keep previous records of that off-box logged somewhere else that you can then do independent comparisons, if it gets to that, yes.
Yeah, so the goal basically is to be that such infections don't happen. So that's the goal of the hardening, that attackers cannot break in. So, because if they broke in, they are hard to detect. The file management that we talked about, the AD or the RPM database verification, is some form of indicator of showing such a thing. There are also rootkit detection scripts, but they only work reliable if you down the system, mount the hard disk read only, and run them on that. Because with a kernel level rootkit, they could hide and move any file away, and you wouldn't ever see it. So the best thing would be avoiding intrusion at all. With this, with hardening methods, with consistent standards on managing IT systems and so on. More questions? Okay, then thank you for listening.